Hey, what's up, Logic fans? Welcome to another video. Today we're going to hit section 4.8, our eighth section on on quantificational symbolization. We're going to hit the mechanics of relations in this video. In the next sequence of videos, 4.9, we'll be covering what the relations actually mean. Okay, so again, we have this sort of division of labor. You want to get down how to construct relational sentences properly. Once you've got that underneath your belt, you can talk about the meaning of them. And once you've got both of those going, you're going to have a really strong understanding of this new symbolic device. All right, let's rock. Okay, in section 4.8, we have a new symbolic device to introduce, and that new symbolic device is going to stand for relations, okay? So I'm going to show you what the symbols look like in a second, but let me first quickly motivate why we need to introduce this new symbolic device. So consider this argument, all right? Intuitively to you, is this argument valid or invalid at an intuitive level? Okay, go ahead and pause it to give yourself more time if necessary. But intuitively, this is a valid argument, right? If Jack is Jill's brother, then Jill is Jack's sibling, and Jack is Jill's sibling, right? So intuitively, this is a valid argument. Therefore, it's desirable we have a means of symbolizing it. And ideally, once we can symbolize it, it would come out valid. All right. So. Unfortunately, right now, as it stands, we do not have a way of symbolizing this, right? We would just symbolize it, that way, A, therefore B, which turns out to be invalid. So what we want to do is we want to look a little more sophisticated, in a little more sophisticated manner at this type of sentence, and that's what relations are going to allow us to do. So in this case, we've got two relations. So you could think of this as saying Jack is the brother, or is a brother of Jill. Jack is a brother of Jill. Okay, so that expresses a relation, right? So the is the brother of relation is what's expressed there. Similarly, we have a relation here, which is Jill is a sibling of Jack. Okay, and that expresses the sibling relation. And so what we need is a way of expressing these sort of is a blank of, right? So a way of symbolizing in relations. So let's take a look at this. We are going to symbolize relations basically the same way we symbolize property constants. So with our property constants, we have fx, fy, fz for any capital letter, a through z, and then any individual constant or individual variable x, y, or z. Okay, so what we're going to do here is we're going to do the same thing. Instead of capital F, little z, what we're going to do is we're going to do capital R, any capital letter will do, and then XY. Okay, so the idea here is that instead of one individual variable, you've got two. Okay, so this would be read X bears R to Y. So X bears, I'll put it that way, X bears R to Y. So for example, if this is the loving relation, this would be read X bears the loving relation to Y, or more intuitively, X loves Y, okay? You do not read it Y loves X. X leads the relation, okay? So these guys here are what are known as relata, or they're the relata of the relation, okay? And we say that X is the first or the leftmost relata, and we say that Y is the second relata. Should say relatum, actually. Singular is the second relatum. Okay, so these guys here are known as the relata of the relation, okay, and the one that occurs in the leftmost position is the first relatum, and the one that occurs in the second position is the second relatum, and it's the thing in the first position, right? The first relatum, which bears the relation to the thing in the second relatum, okay? Which bears the relation R to the thing there. So again, if this is the loving relation, then it's X that's loving Y, and not necessarily the other way around, though possibly. Similarly, if we represented this like RZX, okay? It's the thing in the first position that does it. So in this case, we've got these relata, okay, Z and X, and Z is the first relatum, and X is the second relatum. So in this case, it would be Z loves X, okay? So it's always the thing in the first position that is bearing the relation to the thing in the second position or the second relatum, okay? And relational constants like RZX here are constants just like property constants are constants. So they're constants in the sense that they always stand for the same relation. So is the brother of, loves, likes, or is the mother of, or is greater than, or is taller than, or is faster than. Okay, all of these are relations, but the point is that you can have RZX, you can have FZX, you can have AZX, you can have BZX, you can have ZZX, okay? Any capital letter here, so let's say that this is the taller than relation, so Z is taller than X, okay? The basic idea is that it's a constant in that whenever we say like, okay, this is standing for the taller than relation, then whenever, TXY, TZX, anything like that appears, it will always stand for the taller than relation. It's constant, okay? Now in section 4.9, what we're going to do is we're going to jump into the meaning of these expressions. And so we're going to cover that in detail there. What I want to focus on in this video, okay, or sets of videos on 4.8, is how to properly construct sentences involving this new symbolic device, the relation, okay? So let's jump into how we're going to use this new symbolic device with all of our other new symbolic devices that we've been developing. So officially what we're doing is we're introducing a new symbolic device, okay? And this new symbolic device is the relational constant. And so what we do is we're going to make the new rule QS2, and we're going to basically push all the other rules down one, okay? But basically it follows the exact same pattern as QS1. So with QS1, as you're familiar with, we introduce a property constant appended with an individual constant and surrounded parentheses as a quantificational sentence. So that gets us that this is a sentence, and technically it should be surrounded in those parentheses, right? It also gets us that this is a sentence, and that this is a sentence, and that this is a sentence, right? Okay, so we're already familiar with that. Well, it basically behaves the exact same way, except now we're saying that, you know what, this is a sentence, okay? This is a sentence. Let's do GBC is a sentence, all right? And so it's got to be the same. It's got to be individual constants, not individual variables, okay? And then, of course, the thing should be surrounded in parentheses technically, but just as like with the property constants, we're going to ignore those outer parentheses typically just for readability purposes. All of these are sentences, and you could have, a capital Y here, you could have a capital R here, you could have a capital A here, all right? These are all individual, quantificational sentences by QS2, all right? And you have your individual constants here, and these individual constants can even be the same one. So, so this is a sentence. Okay, that's a quantificational sentence by QS2. This is a sentence by QS2. This is a sentence by QS2. This is a sentence by QS2. Again, the meaning of such sentences eludes us right now, and we'll get into that in 4.9. But again, right now we're just focusing on how we can construct sentences with these things. So that's a sentence, and that's a sentence, and that's a sentence, okay? And then basically what we do is we push all the other rules down. So if you want to add a negation to this, you can, and that will now be QS3, right? If you've got some sentences and you want to, use this, then, you can make this sentence because QS4 is now going to be the and, okay? And QS5 is going to be or, QS6 is going to be if then, QS7 is going to be if and only if, okay? Then you've got the quantifier rules that allow you to tack on quantifiers. So let's jump into some of this in practice and how we can use this new symbolic device in conjunction with all of these rules and get the mechanics of this worked out. Okay, so here's an expression. Show that this expression is a quantificational sentence by application of our rules QS1 through QS 9 or 10 we're up to now. Let me double check that. Yeah, QS10 is now the closure clause, which says that nothing is a quantificational sentence unless it can be built up from QS1 through QS9. So pause now and try this one. Okay, hopefully you've had a chance to pause, right? But this one's pretty simple, right? This is going to be a quantificational sentence by rule QS2. All right, QS2 allows this constants of the same type or two individual constants of different types, okay? So QS2 demonstrates that this expression is in fact a quantificational sentence, and that's all we have to do for that one. Let's try another. Let's try this one here. Go ahead and show that this is a quantificational sentence using our new device here. Okay, this one's going to be pretty simple also, right? It's also just an application of QS2, okay? Nothing big there, nothing too hard, all right? Let's start building up in complexity slowly and easily. Okay, so show that this expression is a quantificational sentence using our new rules, which now include relational constants. Okay, so this one's not going to be too bad, but first thing you're going to do is you're going to build that, and you're going to say that's a sentence by QS2, right? Then, of course, what you're going to do is you're going to want to negate that, which you're allowed to do this way by application of QS3 now is the negation rule applied to line 1. Okay? And this is our little tree that demonstrates that this expression is in fact a quantificational sentence. Okay? Let's try another. Let's try this one. Show that this expression is a quantificational sentence. And again, we don't know what it means yet. We'll cover that in 4.9. But let's just show that it's a sentence. I want you to know how to use the relational constant with all of our other rules. I want you to get the mechanics clear. Okay, so this isn't too bad either, but for this one we can do FA, and that would be, QS1, right? That's just our QS1 rule, no problem there. And then, of course, we want to build this expression, so we're going to use QS2 in order to get that on the board. And notice it follows this rule just fine, all right? Then, of course, what we want to build is the negation of this guy, which isn't difficult, so we can build the negation by applying QS3 to line 2, right? And then what we want to do is bring the whole thing together, right, using conjunction. So conjunction is going to be QS4 on lines 1 and 3, okay? And this demonstrates that this expression here is in fact a quantificational sentence because it can be built up from our rules, all right? So this is a sentence. You don't know what it means, but you do know that it is a sentence and you know how to build it. Let's keep going. All right, let's try this one. All right, let's try this guy right here. This is a little more sophisticated. Show that that's a quantificational sentence. All right, so we want to build everything up that we need, right? So first, let's go ahead and build this guy. That'll be QS2, right? And then, of course, we'll build this guy, which is GC, which is QS1 to get the property constant on the board. Then we want to build this guy, FBJ, and we'll use QS2 in order to do that, all right? Then what we want to do is we want to start building this up slowly. So the first thing we want to build is this guy right here. So we'll go ahead and build him by using, that would be QS6, right? QS6 would now be our if and only if statement. So we're going to do QS6 applied to lines 2 and 3, all right? Then, of course, what we want to do is we want to take some care and we want to build the negation of that next, right? So we want to build that first because the negation always has to apply to the outside of a previous line. So what we're going to do there is we're going to do QS3 now applied to line 4. Okay. So what we want to do now is, of course, finish off the whole deal by building the conditional, and our conditional rule is now QS, let me think here. Pardon me, that should be QS6. Okay, that should be QS6 actually. So QS6 is this one, and so this one's going to be, would have been QS7 is the if and only if now. So QS6 is the conditional, and we're applying that conditional to line 1 and what we obtained in line 5. Okay, and right, so this expression is in fact a quantificational sentence. Why? Because it can be shown to be so by application of our new rules, including this. See you on the next video, 4.8b.